In the previous lecture, we understood very important and very simple functions like first, last, max, mean, sum and all those things. As a part of this lecture, we will understand the statistical functions which are available as a part of the Spark. Let's get started. Before we really venture into this, do I really need to know as a Spark developer all the statistical functions in depth? Not really. As a developer, you got to know there are inbuilt statistical functions available to do some statistical calculations. But depending upon your interest, if you know a bit more about the statistical functions, it will be easy for you to do the development. If you just remember the names of the statistical functions, that would suffice. But if you drill down more and understand the functions bit more in deep, it will help you in a better development. Let's get started with variance and standard deviation. When we talk about the numbers as a part of the data, can we really think of a data without having numbers? Not really. Data tend to have the numbers. When we have numbers, the way we calculated the sum distinct and all those things, we need to look at these statistical functions as well, like variance and standard deviation. Variance and standard deviation, what they do is they measure the spread of the data around the mean. For example, here we have a mean, this is the mean in the center. How the data is spread across the mean, that is what is measured by variance and standard deviation. Variance is the average of square differences from the mean. It is an average of square differences from the mean. On the other hand, standard deviation is the square root of the variance itself. When we come to the statistical functions, some of the functions including variance and standard deviation can be computed on sample data and also population data. There is a difference in that. Whenever your data analyst wants to take all the data which is there involved as a part of a data set, you can just go for a sample variance and sample standard deviation. It all depends on the how your analyst is proposing you to do. But when you think about variance and standard deviation, we do have sample standard deviation and also population standard deviation. As the name suggests, we do have a statistical formula for both of them. You got to differentiate both of them. We will see in a bit how we can differentiate between the sample standard deviation and population standard deviation. Whenever you do not specify anything, Spark performs a sample standard deviation or variance. If you do not specify, Spark thinks that okay, these guys are thinking there should be a calculation of a sample standard deviation and sample variance. You got to import, these are the inbuilt function, that is the good news. You need not really code everything from the scratch. You need to import variance population, standard deviation for the population, variance for sample and standard deviation for the sample. As usual, you got to provide the name of the data frame and select the column on which you want to compute the variance and standard deviation. In this case, we are computing on the column named quantity. Specify these functions on this variance population, variance sample, standard deviation on the quantity, standard deviation sample on the quantity. This is how we use the standard deviation and variance on any particular column in your data frame. Next set of functions are very interesting. The name itself is very different. They are skewness and kurtosis. The people may pronounce it in a different way. You try to pronounce the way it is convenient for you. It is skewness and kurtosis. What they really measure is how are the extreme points in your data. When we are analyzing the data, there are various aspects to measure. One of the measure is how the data is having the extreme points. Skewness measures the asymmetry of the values in your data around mean. For example, here if you see, this is the mean. Okay, is it positively skewed or negatively skewed? This is the positive skew or this is the negative skew. Means if you are having a skewness on the left side of your mean, it is mostly a positive skew, and on the right side it is a negatively skewed. Kurtosis measures the tail of the data. Skewness means like whether you have a asymmetry of the values around the mean, but the kurtosis measures the tail. How is your tail of the data? These both are relevant whenever you are modeling your data as a probability distribution of a random variable. Again, don't try hard. If you can remember the name of the functions, well and good. If you want to drill down, do that please. How do we calculate kurtosis and skewness? Very simple. Please import those two functions and specify the column on which you want to measure the skewness and kurtosis by selecting them from a data frame. Simple. So far, whatever the measures we have discussed, all of them are mostly single column ones. But do you think the data analysis only includes only the single column ones? Not really. The data analysis involves multiple columns as well. Whenever you want to compare the interactions of the values in two different columns, that is when covariance and correlation comes into picture. Correlation measures the Pearson correlation coefficient, which is measured between -1 and +1. The covariance is scaled according to the inputs in the data. The way we understood variance can be computed both on the sample and also population. In the same way, covariance is also calculated either in a sample or in a population. But on the other hand, correlation do not have any notion of having a sample or population. It is just a correlation, okay, between the two columns. That's it. How do we use them to measure the covariance and correlation? Again, you import these functions from our SQL.functions package. Select the names of the columns on which you want to compute correlation and covariance. Select them and specify the function. You can see so far we have been specifying one column. Now this is a measure between the columns. That is where we are specifying two columns. We are trying to get the correlation between invoice and quantity. We are trying to covariance between invoice and quantity. Just to take an example, let us say you visit a retail store. Usually, if you have observed, if the price of the quantity is less, you tend to purchase more quantity of the items. What it means is both of them are negatively correlated. Means if one goes up, other comes down. If this goes up, if price goes up, the quantity comes down. That is one of the simple example of correlation. As we have discussed, Spark is an intelligent computing engine. It will not only allow aggregation on numerical values, it will allow aggregation on the complex types also. For example, what you can do, you can collect a list of values present in a given column or only the unique by collecting to a set. So, we do have couple of functions like collect set and collect list. What is the use of this? What you can do is, you can take a particular column, collect that to a set or a list and use that as a part of any other user defined functions. Wonderful. We discussed many important statistical functions and also we understood aggregations can be done on complex types. Thank you.